Hi, and welcome to Algebra Examples. I'm Dr. Finch. Today we're going to be looking at finding the limit as x goes to infinity of the quantity natural log of 1 plus x squared minus natural log of 2x. And we're going to use some nice algebra to understand how we can make that a little bit easier to work with. Now, first of all, before we get anywhere at all, we have to remember what the natural log of x looks like on a graph. There are very few things that you should memorize for a math class. This is one of them, at least if you're taking a calculus class. Here's our graph of natural log of x, and you'll see as x goes to infinity, our graph also goes off to positive infinity. So if we plugged x into our limit right here, we would get infinity minus infinity. Oops, minus, not equals to, which as we know is undetermined. So we got to actually do some algebra to figure out what's going on there. There are some few things that we have to use for our algebra. Actually, there's just one in particular, and I actually kind of like this one. If you have natural log of A minus natural log of B, you can rewrite it as the natural log of A divided by B. We're going to put that in a little cloud here. This is a super useful tool to have at your hand to remember, at the very least have it next to you while you're doing your homework. Now this works for logs as well, not just natural logs, which are logs based E. In this case, however, and in most calculus classes, you don't deal with regular logs that often. It's almost always just the natural log that you're working with. Okay, so in this case, let's rewrite our limit as x goes to infinity. And we're going to take and we're going to shove those two things together into a quotient. Our top is going to be 1 plus x squared, and the denominator will be 2 plus x. So now we have a limit that we're looking at, and it looks a lot better. However, if we put in infinity at the moment, again, you'll see, oh, things just don't turn out very well, do they? Because you'd end up with natural log of infinity divided by infinity, which is again a problem, right? So we've got to do a little bit more work here. When we have a polynomial divided by a polynomial, one of the things that we want to do is take out a variable on the top and the bottom so we can cancel some stuff out. So I'm going to do this in two steps. I'm going to start off by rewriting the top. What we're going to do is we're going to pull a single x out. So I'm going to rewrite 1 as 1 times a fancy 1, and our fancy 1 is x divided by x. Our x squared we're going to write as x times x. We're going to do something similar in the denominator. We're going to 2 times a fancy 1 plus, and instead of just x, we're going to talk about it as 1 times x. Okay, now we are going to be able to pull a copy of x from both the denominator and the numerator. This is going to leave us with 1 over x plus x up top. And in the denominator, we get 2 over x plus 1. Those x's are going to cancel. And now we have the limit as x goes to infinity of natural log of 1 over x plus x over 2 over x plus 1. The other graph that we're going to use today, and this is another one that really you should know off the top of your head. Thank goodness we are not in a biology class. They have to memorize all kinds of stuff. Okay, is the graph 1 over x? Or, I mean, any number over x is going to look somewhat similar. And you'll see that what happens is as x goes to infinity, our graph goes towards 0. So in this case, 1 over x, this thing is going to go to 0, 2 over x, that is also going to go to 0. And we're going to be looking at approximately natural log of x divided by 1, right? And as x goes to infinity, we saw in our original graph, that is going to go to infinity. So our solution here is going to be a positive infinity at the end. Now, one thing I do want to point out as a side note is something not to do. And it's very tempting to do this, right? We have the 1 over x plus x over 2 over x plus 1. When we had the x squared in the numerator, you know, my instinct is wondering what happens if we pull out a second x in the numerator and a second x in the denominator, right? If we did that, not only would our x's cancel, but here's the problem. 2 over x squared goes to 0, 1 over x squared goes to 0, and then we are dividing by 0. So that is definitely not good. So this is why we only want to pull out one x to solve this problem and not two. I would say in this case, play around with things. If you don't find the right solution right away, this is why we try and try again. Thank you for listening.